Right, this is a 2014 external question 2. I can see this is the question dedicated to the normal distribution. We're talking about BMD, bone mineral densities, are normally distributed, a mean of 950, and a standard deviation of 125. What is the probability that a 25-year-old male has a BMD of more than 1,000? So 1,000 is going to be here, and the probability of having a BMD greater than that would be a right tail. So we want the probability of having a BMD greater than 1,000. And if we go to our calculator, we're going to stat, distribution, normal. We've got a lower bound of 1,000. Upper bound, we'll put in some gigantic number. We've got a standard deviation of 125 and a mean of 950. There's our answer, 0.34457. Right, part 2. Her BMD has a Z value of 0.49. What is her actual BMD measurement? Now, there's a formula for converting between values on the BMD scale that has a mean of 950 and the Z value scale. Now, this is from the standard normal curve, which has a mean of 0 and a standard deviation of 1. It's got a Z value of 0.49, which must be up here somewhere. And we want to convert that to a measurement on the BMD curve with a mean of 950 and a standard deviation of 125. So looking on our formula sheet, the formula is x minus mu divided by the standard deviation equals the Z value. Okay, so we know the mean, that was 950. Standard deviation was 125. We're told the Z value is 0.49, and obviously all we're looking for is x. Now you can use solver on the calculator. You'll need to remember to put brackets around the top line when you put it into solver, and out will come a value of 1011.25. We might want to check what the units are, and up above I can see the milligram per centimetre squared. Those of us working out by hand trying to solve this, we would multiply by 125 and then obviously add the 950 to the answer of that one. Oh, that's times 125. And you get the same answer. Right, part 2. Proportion would be expected to have a BMD that is less than Jane's. Now, Jane's is the 1011.25, so we want the probability of having a BMD less than Jane's. Of course, this relies a wee bit on having the question above correct. I can see it's all this area there, so it's certainly more than 0.5. We have an upper bound this time, so bringing in the calculator. So a lower bound, I'm going to choose something small. Our upper bound is 1011.25. Same standard deviation, same mean, 0.6879, and we suspected it was bigger than, we knew it was bigger than 0.5. Right, this time we're looking for a mean. It's a backwards question. So these will be the BMDs of the males. They have a standard deviation of 150. We're asked to find the mean. We'll make this our Z curve, standard normal curve, with a mean of 0 and a standard deviation of 1. We're told the probability a randomly chosen male has a BMD above 1000 is 0.656. Now, this is more than half. The probability that it's above 1000 is 0.656. So that tells me that the 1000 must be on this side of the mean. So that the probability of having a BMD above that is more than a half. It's 0.656. So what we need to do is go into our standard normal curve and find out what the Z value is that corresponds to 1000 on that curve. I can tell this is an inverse question. We're looking at a right tail. The error is 0.656. The standard deviation is 150. When we come to put in the mean, we realize we don't actually have the mean, and that's why we need to be working this out first of all on this standard normal curve with a standard deviation of 1 and a mean of 0. And there's my Z value down the bottom here, is negative 0.40157. So we'll just put that away, bring this one back, and that value there is negative 0.40157. Right, so I've changed from 1000, converted from 1000 to that value. Remembering the formula, so we don't know the mean, we know the standard deviation was 150, we know the Z value is negative 0.40157, and the X value was 1000. Right, now you can do that in Solver. You'll need to remember brackets around the top line, and when you do that on Solver you get a value of 1060.2, and let's remember the units. I can find them in the question. Have a look back at your picture. It sounds feasible that the mean of course has to be bigger than 1000, and 1060 is. You can of course also solve this equation by hand and end up with the same value. Right. Test has questions of varying levels of difficulty. Consider the graphs and tables shown on pages 6 and 7. We might just pause here and continue this question with another video.